Okay, so now I guess it's time to finally start looking at the spectroscopy data. So I'm going to open up the flat file directory, and you see here we have, remember I did one single point spectroscopy measurement first, and then so that's why this first IV file is 1_1. So there's only one. Every time you click or activate the spectroscopy, it'll increment this first number. And if we took multiple repetitions, then it increments the second number. And so the fact that there's only 1_1 means it's just one of those first spectroscopy files. And then when you look at the next one, 2, so 2 underscore, there's 2_1, 2_2, 2_3, 4, 5, 6, 7, 8, 9, 10. So just remember, we in the second measurement, we set the repetition number to 10, and we clicked and we got 10 repetitions in 1. So I guess first of all we could just look at this first one here. So 1_1. I should be able to drag that onto Igor, and there we get the IV curve. And as you can see over here, this is the Igor data browser. If that window is not visible for you, then you can go data here, data browser, and bring it up. Likewise, the command window here, that's quite useful sometimes. And here, so if you want to bring that command window up, it's Windows and then command window. And anyway, in the data browser, you can see you have the ability to make folders. And so when in the macro, when you load in the data, it gives the data a name. I can't remember if it extracts it from the file name or if it gets it from the metadata for the flat file itself. But in any case, it names the file appropriately, or creates a folder that's named appropriately, and then it puts the data inside that folder. And Igor calls the data that you've loaded is called a wave in Igor, and you can you can see that when I click on the wave, that I'm getting down here textual information about what that wave is. So it's telling me that these are 32-bit floating point numbers, telling me that the data has got 500 data points, etc., etc. And you can also see here a preview of the data itself. And if you don't see those in your version, then you can see there are these options here. So if I click this, if I turn off info, then I don't get that little info box. And if I turn off the plot here, then I don't get the little preview plot. But both are really useful, so I recommend that you turn both of those on. And you can see the data, the macro, as it's loaded the data, it's separated the trace and the retrace. And in the plot, then it's plotting both of these, and these are separate waves. So if I double click on one of the traces, then you can see I'm able to sort of edit the properties of the trace. So if I can make the retrace black, for example, I could add an annotation here. Let's say legend. I'll just leave the default values. Okay, so you can see that the red trace here is the forward, the sort of forward trace, and then the black trace is the retrace, and those are overlapping reasonably nicely. So what we would like to do with tunneling spectroscopy data is differentiate it, because what we have here is current as a function of voltage. What we'd really like to look at is dIdV as a function of voltage, and that means differentiating this data with respect to voltage. Okay, so if we go up here into the menu, so the STM menu has tools for looking at sort of two-dimensional data, so the image data, or the three-dimensional spectroscopy, the position-dependent spectroscopy data, CTS. For data like this, where we just have a point spectra, then those functions are in this line trace menu. And yeah, so there are various these organizers for doing things with sort of multiple traces, and manipulate is kind of for doing things with the for differentiating and smoothing and so forth. These are all functions that I've written, everything into these two windows. You do still maintain all of the usual Igor tools, so you can just Igor has a differentiate, curve fitting, and all of these things built into it. So you can use those as well if you prefer. But for a lot of these standard things that we do with our STM data, I've kind of made these functions that sort of do the things that we need to do most often. So here we have one that's called differentiate all traces, and so however many, here I've got two traces on this window, the forward and the reverse, and however many traces are in that window, it will differentiate. And the functions in Igor, the function generally when you execute a function, it operates on whatever is the window that's at the top at the time. So if you have more than one windows, then you have to click on the one that you want to do something on to bring it to the front. So if we go manipulate and differentiate all traces, now we get this window here, which is now our DIDV as a function of voltage. And I'm going to double click on this. You can see, so we have there's two waves, and the retrace here, let me make that one black as well, just to be consistent with the first window that we have. So you can see it's very noisy. I guess also if you look over here in the data browser window, you notice that we have, before we had these two waves, which were the undifferentiated data. So what the macro package is doing is it's duplicating those data. Well, it's differentiating them and then saving the differentiated wave into a new wave here. And it's appending this capital D at the end just to let you know that is data that you've differentiated. So this is obviously not that great. In principle, you have a band gap here. This is the valence band over here. This is the conduction band, and this is your band gap. But somehow this data is not showing this extremely well. So that's the reason why we like to take multiple spectra. So what I could do is I could start to load in these. So let's say if I take 2.1 and 2.2, and if I just load these in, then I get, okay, these are my two new waves that are point spectra that I've loaded. Here, okay, so I've somehow moved into this directory, this IV directory. So I want to go back up into the root directory. Okay, yeah, there we are. So here, so this is the root directory, and you can see that when I loaded in the first wave, it created this data folder IV11, and when I loaded in the next two, it created this IV21 and the IV22. And normally we like that. You load in one image, it's nice. All the information for that image goes in that single data folder. But for the case where we've got these multiple IVs, I actually want them all to be loaded into the same data folder. So I'm just going to close all of those graph windows, and I'm going to delete these data folders. Okay, so maybe it's a good time here just to point out another couple of things quickly. You might have noticed that when I look at these individual data folder windows here, there's another data folder, matrix info. And if you open that, you can see there's a whole lot of variables, a whole bunch of more folders and different variables. And this is the totality of the header that you get with the flat file. So all of the information that's contained in the header of these flat files gets loaded into all of these variables. And I loaded them all in because they're all there, but in practice you don't really need them. So in principle, we could, I can't really think of a case where I've actually needed the information that's stored in there. It's just there in case we do need it. But so you don't need it. You also don't need to delete it. So it just sits there. But the one I want to point out now is this folder here, Win Globals. So win globals is associated with the macros that we've loaded. So for example, when you use this global program control to change the various behaviors of the macros, what it actually does is it changes a variable inside the win global. So it's actually inside this SRS STM control. You can see there are a bunch of variables, and those get changed when you change the options in this global program control. These image 0, image 1, these contain some information about the graphs that we plotted earlier. And so we don't, since we've already closed those graph windows, we don't really need those anymore. But I just wanted to highlight, because right now what I want to do is I just want to delete these IVs because I'm not interested in them anymore. So I can select them and right click and delete them. I also can delete this win globals, that's no problem. And delete the win globals, and what you'll see is that when I when I interact with this menu, the program recreates the win globals. But just one thing to be aware of, that if you delete the win globals and it recreates them from scratch, and so all of these values here will go back to whatever their default values are. Okay, so that's just sort of a little bit more of technical information. And what I'm going to do now is I want to use this global program control, because in here, okay, so there's this option here, load all flat files into my data. And so when I select that option, now what's going to happen is that when I load the IV curve, it's not going to create a data folder named after the IV curve. It's just going to create one that's called, I guess it's called my data. So I'm going to select all 10 of those spectra that we took. Remember, these were the 10 repeats. And I'm going to load those in. And you can see now, as I said, it's loaded that now all of these IV curves into this one data folder. And that's quite useful. And now if I were to load in another IV curve, it would also go into my data. So what I'm going to do right away before I do anything else is just go my data, and I'm going to put _2. That tells me, you could write whatever you want, but I'm just using 2 because this is the spectroscopy file 2. So now I could, for example, take the IV, the 3 spectroscopy. I can load those in, and they go into my data, and I can underscore that one with _3, for example. So now let's look at the data. And so what we can do is, if we go up to line trace, you can see display, and it's got display a wave, or it's got here display all waves. So by selecting the data folder my data 2 and saying display all waves, that will then show me there are 20 waves there are 20 IV measurements in that data folder, because we took 10 repeats, and for each repeat there's a forward and a reverse trace. And okay, so they're actually reasonably reproducible, so that's kind of nice. Again, we could pick one and change the color. Right, so there's one wave we made black. But the reason that we took the 10 repeats is because we want to average them. So we can go in here into manipulate. So you could do differentiate all traces, and that will give us again. So now we have here in this window, we have now 20 traces that have been differentiated. We've got 20 new waves in the data folder with this _D, and then we could average these differentiated plots by manipulate and average all traces in the graph. So by doing that, we now have this window here. This is the average of all of those traces. Or conversely, you can do that. Obviously, you can do that in reverse. So average all the traces, and then we could differentiate all traces, but in that case, there's only one. And we could also smooth the data. We have in here various options for smoothing. So let's just run one of these. And that, so here now I've actually smoothed all 20 of those, and then I could average the 20 smooth traces, and then I could differentiate that smooth one. And of course the result that I get should be the same as if I doesn't, these are all, doesn't matter what order that we do these operations in. Whoops, I smoothed the wrong one. So that one's now been smoothed twice actually. How did I manage to do that twice? Manipulate, smooth. Okay, maybe something's. Oh no, I'm being silly. So it is smoothing the data that I told it to, but it's then creating a new graph, and it's just recreating the new graph at the same position as the old graph. So yeah, so it didn't smooth twice. Okay, and now you can see this looks quite a bit better, more like a valence band and a conduction band. Yeah. Okay, so before we go any further, I want to show you a little bit the way the macros are set up, because whenever you do any analysis of your data, it's very important that you understand exactly what has been done to your data. So at the moment, we're just clicking this magic smooth button up here, and the data is coming out smoothed. But what actual smoothing is being done, and that goes not just for the smoothing, but for any of these operations. And so what I want to show you now is kind of the structure of the macros, so that you kind of look at the code and figure out exactly what has been done. And it's a little bit convoluted, but it's not that bad. So if you want to get to the programming part, then you click on this tab here, Windows, and we go down to Procedure Windows, and then over here you can see these files, and these are the files that have been loaded when we loaded the macro package. And I've organized these so you can see there are files that have STM. Those generally are the ones that operate when we go to this STM menu, and the other ones are the ones that operate when we go to the line trace menu. These have switched orders because I was just, while I wasn't screen recording, I was just looking at reminding myself how these work, and apparently when it's reloaded, it's put the two menu items around the other way than they were before. But anyway, so we go Procedure Windows, and the way to figure out how anything works is to first of all load the file that handles the menus, right? These menus are also have been programmed, and those menus are in the two files. So here we've got the line trace menu, and down here we've got the STM menu. Okay, so right now we're interested in the line trace menu, so I'm going to open that file. Right, so this is now this is code written in Igor's own programming language, and this is the code that defines this menu, and it's fairly straightforward to read. So sub-menu line trace, sub-menu display, and then it's got what is being displayed on the menu when you click it, and then in black here, this is the function that gets run when you click that option. So we're interested in line trace, manipulate, let's say smooth all traces. Let's say we want to know exactly what this function is doing. So we need to go down to the manipulate submenu, and then you can see here the smooth all traces. It calls this function that I have named do something to all traces in graph. Yeah, and then it takes some options. So here it's saying the thing that it's going to do is do whatever is defined here by smooth -b. So the next thing to do is to find this function, and you can sort of do Control F and find it, but I know that it's in, there's also not a huge amount of files here, so I know that it's in this file here, line trace functions. Like I said, you can actually do Control F and it'll search through all of these files. But I'm just going to select this one here and open it up because I know it's in there. These forward slashes, these are obviously your comments, and I can't guarantee that I've done it all perfectly, but quite often when I've written a function, I try to add the name of the function up here to the top so that you can see the functions that are in there, so we can see right away that the function that we're looking for, do something to all traces in graph, is in this file. But this file also contains all of the various manipulations that we're doing to the line traces. So let's actually go ahead now and do the Control F, and we want to search for what was it? Do something. Well, let me just copy. So I'll copy this, type it into the find window. Okay, so here we are. So function, do something to all traces in the graph. So this is the function that gets called when we select here smooth traces binomial, and it gets called with type equal to smooth hyphen b. So now we can look through the code to see what happens. So here you can see there's a, sorry about that, I don't know why my email's opened. No, go away please. Yeah, okay, so here you can see a switch statement, and it's saying if it's called with smooth B, then it's this is a prompt. So that this part is only the prompt. So remember when we do, let me select one of these windows, and then I go manipulate smooth all traces binomial, and remember it comes up with this prompt here. So that's happening here in this little switch statement here. So it's asking me to enter in the smoothing factor. But that's not actually doing the smoothing itself, so I think we need to look a little bit further down. So here we can see there's another switch statement, and this seems to be where some of the action is happening. So if we go here, okay, so now we see case smooth hyphen B. This is the part where it's defining, how to change the name of that wave. It appends this underscore SB onto the wave. And okay, so finally now we can see it's calling yet another function. So this is calling a function smooth a wave B. So let's now just search for that function. Okay, and finally we get to this function here, smooth a wave B. You can see it's taking the wave name and the smoothing factor. This is the number that we type into that prompt box. And finally you can see all that function is, all that is doing is calling this built-in Igor function smooth. And so it's smooth, some number 3 or 4 or whatever you type into that box, and then the wave itself. So we need to go a little bit deeper. So what actually does Igor's smoothing function do? So then we can go to the command help for Igor, and we can find the smooth function in there, and then you can see now there's detailed information here about what the smooth function does. So it's like I said, slightly convoluted. There's a sort of a sequence of steps that you need to follow through, but with that with that methodology, you can figure out what any of these macro functions are doing with a little bit of effort, and that'll help you to understand what the functions are doing. But also, if you decide that you want to make some modifications, if you want to try, Igor's got many different types of smoothing that I haven't implemented in the smoothing functions. So you could play around with those for example.